From the dawn of consciousness, we have looked to the heavens. The silent, diamond-dusted canvas of the night sky has been our greatest source of wonder, our most profound mystery. It is a chronicle of our past and a map to our future. For centuries, we saw only points of light. But today, through the lens of science, those faint glimmers have resolved into worlds, galaxies, and cosmic enigmas that challenge the very foundations of our reality. This is the story of that universe, our universe, and the great unfolding quest to understand our place within it. Our journey begins not in the distant cosmos, but in our own cosmic backyard, with a question that has haunted humanity for millennia. Are we alone? For most of history, we knew of only 8 planets, all orbiting our sun. They were our companions, but they appeared barren, either scorched by fire or locked in ice. The great interstellar void seemed just that, void. But we were looking with limited vision. In the last few decades, a revolution has taken place. Our technology has finally caught up with our ambition, and we have opened our eyes to a galaxy teeming with worlds. These are the exoplanets, planets orbiting stars other than our sun. Using ingenious methods like observing the subtle dimming of a star as a planet transits in front of it, or measuring the gravitational wobble a planet induces in its parent star, we have uncovered a staggering planetary census. We've found more than 5,000 confirmed new worlds, and that number grows with each passing week. And they are a bizarre and wonderful menagerie. There are hot Jupiters, gas giants orbiting so close to their stars their atmospheres are boiled away into space. There are super-Earths, rocky worlds larger than our own, whose crushing gravity might make life as we know it impossible. We've even found planets orbiting 2 stars at once, where the sky would offer a double sunset, a scene once relegated to science fiction. But the ultimate prize in this celestial hunt is the discovery of a true Earth twin, a rocky planet, similar in size to our own, orbiting its star within a special region known as the habitable zone. This is the Goldilocks region, where conditions are not too hot and not too cold for liquid water to exist on the surface. Water, as we know it, is the crucible of life. The James Webb Space Telescope, our most powerful eye on the cosmos, is now peering into the atmospheres of these distant worlds, searching for telltale biosignatures, the chemical fingerprints of oxygen, methane, or water vapor that could betray the presence of a living, breathing biosphere. The stakes are profound. To find even microbial life on another world would be to answer a fundamental question about our own existence. It would mean that life is not a fluke, not a miracle unique to this pale blue dot, but a common cosmic imperative. As we pull our view back from these individual star systems, we begin to appreciate the grand structures that house them. Our sun, with its family of planets, is just one of at least 200 billion stars bound together by gravity into a colossal, spinning pinwheel of gas, dust, and light, our home galaxy, the Milky Way. From our vantage point on a spiral arm, 2/3 of the way from the center, we see its shimmering band stretched across our night sky. At its heart lies a dense, luminous bulge, a chaotic city of ancient stars. And at the very core of that city, a monster sleeps. Sagittarius A is a supermassive black hole more than 4 million times the mass of our sun. Its immense gravity choreographs the orbits of the stars nearest the galactic center. But our galaxy is not unique. Through our telescopes, we see them scattered across the cosmos like jewels on black velvet. There are hundreds of billions, perhaps even trillions of galaxies in the observable universe. They come in majestic spirals like our own, colossal spherical cities of old stars known as elliptical galaxies, and chaotic misshapen forms called irregular galaxies, often the result of cosmic collisions. Galaxies are not static. They are dynamic, evolving entities. They grow by consuming smaller galaxies, and they engage in gravitational ballets that can span hundreds of millions of years. Right now, our nearest large galactic neighbor, Andromeda, is hurtling towards us at over 400,000 kilometers per hour. In about 4.5 billion years, our 2 galaxies will begin a slow, spectacular merger, their spiral arms interweaving to eventually form a new giant elliptical galaxy. Long after our sun has died, the stars of our galactic home will have been rearranged into an entirely new celestial landscape. This cosmic dance of creation and collision is the engine of galactic evolution, a process that has shaped the large-scale structure of the universe since the beginning of time. Yet within these grand cities of stars lurk objects of such extreme physics they defy our everyday intuition. These are the black holes. They are not holes in the traditional sense, but rather an astonishing amount of mass crushed into an impossibly small space. Stellar mass black holes are the tombstones of the universe's most massive stars. When a star more than 20 times the mass of our Sun exhausts its nuclear fuel, it can no longer support its own weight. Its core collapses catastrophically under its own gravity, triggering a supernova, an explosion that for a brief time can outshine an entire galaxy. What's left behind is a gravitational ghost, a point of infinite density, a singularity. The defining feature of a black hole is its event horizon. This is not a physical surface, but a boundary in space-time, a point of no return. Cross it, and gravity becomes so overwhelmingly powerful that escape is impossible. Not even light, the fastest thing in the universe, can break free, which is why black holes are black. For decades, they were purely a prediction of Einstein's general theory of relativity. But in 2019, science achieved the impossible. Using a network of radio telescopes spanning the globe, the Event Horizon Telescope, we captured the first ever direct image of a black hole S-shadow the silhouette of the M87 Galaxy's supermassive behemoth, 6.5 billion times the mass of our Sun. There it was, a ring of light, composed of superheated plasma swirling around the abyss, perfectly framing the inky blackness of the event horizon. Einstein was right. The monsters in the dark are real. And yet, as we mapped the stars, the galaxies, and the black holes, a creeping realization dawned on astronomers. Everything we could see, every star, every planet, every grain of dust, only accounted for a tiny fraction of the universe. The cosmos, it seemed, was mostly invisible. This revelation gave birth to one of the most profound mysteries in all of science, the twin enigmas of dark matter and dark energy. The first clue came from the rotation of galaxies. Stars in the outer arms of the Milky Way are moving far too quickly. According to our understanding of gravity, they should be flung off into intergalactic space, like children falling from a carousel that's spinning too fast. There simply isn't enough visible matter, stars, gas, and dust, to provide the gravitational glue needed to hold the galaxy together. The only explanation is that galaxies are embedded within a vast invisible halo of something else, something that has mass and gravity, but does not interact with light in any way. We call it dark matter. It is the invisible scaffolding of the cosmos, the unseen mass that dictates where galaxies form and how they hold together. Despite comprising about 27% of the universe's mass-energy content, we do not know what it is. It remains one of science's greatest ghost hunts. But the mystery deepens. In the late 1990s, astronomers studying distant supernovae made a discovery that shattered our understanding of cosmic destiny. They found that the expansion of the universe, which began with the Big Bang, is not slowing down as expected due to gravity. Instead, it's accelerating. Something is pushing space-time apart, a repulsive force acting in opposition to gravity. We call this force dark energy, and its prevalence is staggering. It is believed to make up roughly 68% of the entire universe. Normal matter, the stuff we are made of, constitutes a mere 5%. All of human history, all our science and art, all the stars you see in the sky, are just a sliver of froth on a vast, dark, cosmic ocean. We are living in a universe whose fundamental composition and ultimate fate are governed by forces we have yet to identify. This realization that our reality is just a fraction of the whole forces us to ask an even more audacious question. If our universe is so much grander and stranger than we ever imagined, is it the only one? This is where science pushes into the realm of the truly mind-bending, to the theory of the multiverse. This is not a fantasy, but a plausible consequence of some of our most robust physical theories. According to the theory of cosmic inflation, our best model for the explosive first moments after the Big Bang, the event that created our universe may not have been a one-off. It's possible that inflation is eternal, constantly bubbling off new universes, each potentially with its own unique set of physical laws and constants. Another path to the multiverse comes from string theory. In its attempt to unite gravity with quantum mechanics, string theory posits the existence of extraspatial dimensions beyond the three we perceive. Our entire universe could be a three-dimensional brain floating in a higher dimensional space with other brain universes floating parallel to ours, perhaps only millimeters away in another dimension, but utterly inaccessible. Then there is the many worlds interpretation of quantum mechanics. It suggests that every time a quantum measurement is made, reality splits. Every possible outcome happens, each in its own separate parallel universe. In this view, there exists a near-infinite array of alternate realities, one where you made a different choice this morning, and another where the dinosaurs were never wiped out. It is crucial to state that we have no direct observational evidence for any of these other universes. They remain on the furthest frontier of theoretical physics, but they represent a logical, if staggering, extension of our cosmic journey. We went from believing the Earth was the center of everything to realizing it's a planet around a star, in a galaxy among billions, in a universe made mostly of invisible stuff. The next logical step could be the realization that our entire universe is just one of many. From searching for new worlds to mapping galaxies of stars, from peering into the abyss of a black hole to confronting the vast dark unknowns that dominate reality, from pondering our cosmic origins to questioning the very existence of other universes. This is the modern voyage of discovery. The story of the cosmos is the story of a humbling progression. With each new discovery, the universe reveals itself to be larger, more complex and more mysterious than we could ever have conceived. We are living in a golden age of astronomy, armed with tools that our ancestors could only dream of. Yet the greatest revelations may still lie ahead. The night sky is not just a vista of what is, but a testament to the power of a single, enduring human trait: curiosity. It is the desire to know what lies beyond the next hill, beyond the next ocean, and beyond the next star that continues to drive us forward. The journey is far from over, and as long as we keep looking up, we will keep finding wonders.